All right, let's take a look at section P-5, factoring polynomials. Now, factoring is one of those skills in math that, regardless of what math class you're in, it's going to be important. Whether you're talking about basic math and just factoring numbers, or whether you're talking about calculus and factoring very complex equations, factoring is something you're going to see everywhere, forever, for your entire math career. That being said, obviously it's something that's going to be very important. So in this section, we're going to look at a few different methods for factoring, and for the most part this year, I'm fine if you use whatever method you like for factoring, as long as it works for you. I have methods that I like that work for me, and if you don't like the method that you use, I'd be happy to teach you some of my methods for factoring. But if you're happy with the way you factor, that's completely fine with me, as long as you're showing me work and how you did it. So let's look at the first type of factoring, factoring by grouping. And that's exactly what it sounds like. We're going to group terms together and factor them. So looking at these two terms here, we want to pull out the greatest common factor. And so again, like it says up here, what you always want to do is look for a GCF and pull it out. So we're looking at the GCF of these two terms, greatest common factor. And our greatest common factor is going to be x squared. And what we have remaining in that little factor here is going to be x plus 6. Now, in this next group here, our greatest common factor is going to be -2. And so left in that little set of parentheses there is going to be x. And this is probably the part that students have the most trouble with. What sign goes here? Well, if I'm distributing this negative, I need this to be a negative. So distributing this negative, in order for that to stay negative, this has to be positive. Now this is the part that's kind of hard to see, but notice here that we have a common factor in this term and this term. That common factor is x plus 6. So let's go ahead and pull that x plus 6 out front. And what's left is x squared minus 2. Well, some people might stop here, but we can take this a step further if we'd like to. This is a difference of squares. So I have x plus 6, x minus square root 2, and x plus square root 2. And that is as far as we can factor this polynomial. Okay? Now next we have factoring using the x method. Okay, now this is my own method that I've kind of come up with over years of teaching, and I think it works great. If this equation is factorable, this will work. You'll be able to find your factors. Now the first thing I always want to do is pull out my GCF, and looking at these terms, I do have a GCF, and that would be 2. And now with what I have left, I'm going to use what I call the x method. So I have ax squared plus bx plus c. And what I want to do here is I want to put a times c up top, and I want to put my b on the bottom. And what I'm looking for here is two numbers that multiply to whatever I have up here, and two numbers that add to whatever I have down here. Well, looking at this specific example, my a value is 3 and my c value is -5. So I have -15. And then on the bottom, I have a b value, and that's going to be -2. So I'm looking for what two numbers multiply to -15 and add to -2. And you can list out the factors of 15, but I know off the bat that this is going to be -5 and 3. And what you're going to do next is every time you're going to put your ax term here and here. So I'm going to have 3x minus 5 and 3x plus 3 using these two terms right here. Now oftentimes, I need to remember my 2 out front. Oftentimes this is where students kind of look at me confused and say, well, that's too many 3's here. Which one has the 3? And what you're looking for here is the step that I call taking out the trash. I know that I have too many 3's here. And the one that it's a common factor with is where the trash is. There's trash here. There's a common factor of 3. And so this is taking out the trash. And that reduces out. And we're left with 2, 3x minus 5, and x plus 1. Now for some of you, factoring this, you could probably do it in your head. And to some degree, that's fine. I would like to see some work. But you can use your own method. But as these numbers get bigger and bigger and bigger, and the equation looks more and more complicated, having a method that you can go to can be helpful sometimes. All right, so now we can also use factoring using special factors here. So if I have the difference of 2 squares, I can just factor like that. If I have the sum of 2 cubes, we have 2 equations here, and the difference of 2 cubes, we have that equation right here. So we can use both of those. Now let's go ahead and get to our last example here. It says factor using the formulas above. So first thing I always want to do I have any common factors here? And in fact, yes, I do have some common factors. I have a common factor of 3. So I can pull a 3 out from both of those. And 81 divided by 3 is 27. And 24 divided by 3 is 8. And what I'm noticing now is that these two numbers here are perfect cubes, and it's a difference of 2 cubes. So I can use this formula right here. And if I'm using the formula, my A value is going to be 3x, my B value is going to be 2y squared, and then it's just a matter of plugging into the formula. So I have my 3 out front, and then A minus B is going to be 3x minus 2y squared. And then I have a squared. Well, this is going to be 9x squared. Biggest mistake I see students make is just write 3. Don't do that. You want to make sure you square the whole thing. Plus a times b, that's going to be 6xy squared. And then plus b squared, so plus, again, square the whole thing, so 4y to the 4th power. And that's how we can do that. All right, and that is the end of section 5.